Hi, my name is Peter Hakel, and my project is a refrigerator or a freezer in this case, which I have in a garage that is not working, but for this project is great. First thing, how the refrigerator works is that the refrigerator removes the heat from inside the refrigerator and keeps it around 39°F for the refrigerator and 0°F for the freezer. We have a compressor right here at the bottom usually of the freezer. When it starts to run, it takes low pressure refrigerant vapor from evaporator from the coils inside the refrigerator and compresses it. This raises the pressure and temperature of the refrigerant and turning it into hot, high pressure superheated vapor. Then the hot refrigerant gas goes to condenser coils. Usually they are on the outer side of the refrigerator. In this case, they are hidden. And as the gas cools down, it condenses into high pressure liquid. The refrigerator then passes through the expansion device, the capillary tube. So the high pressure liquid is forced through the very narrow tube. And this causes the sudden drop in pressure and temperature and turning the liquid into cold liquid vapor mixture. Then the cold refrigerant goes inside the refrigerator into evaporator coils inside, and it absorbs the heat from inside, and the refrigerant turns back into low pressure vapor. And this process basically cools down the space inside the refrigerator, and then it goes down back again, and the cycle repeats, goes back to the compressor and repeats again. My first concept is closed system. So we have a refrigerant inside the refrigerator that is continuously cycling in the components and the tubes. So the components that are inside is the evaporator, compressor, condenser, and capillary tube. The only thing that is changing is temperature, pressure, and a phase from liquid to vapor. The refrigerator as a whole is open system because the warm air enters in from food and from surrounding room. However, the refrigerator system is closed system because no mass enters the system and no mass leaves the system. My second concept is heat transfer. So the heat inside the refrigerator is removed mainly by force convection. The conduction occurs through the metal coils, walls, and the insulation. The goal is to maximize the heat transfer inside the refrigerator and minimize the heat leak throughout the insulation and the door gasket. My third concept is vapor compression refrigerator cycle. So the refrigerator has a heat engine compressor that moves the warm air from cold to hot. There are four main processes: the evaporation that absorbs the heat inside the refrigerator, compression that the compressor adds the work and raises the pressure and temperature, condensation that it releases the warm air into the surroundings, and the expansion that the pressure drops suddenly through the capillary tube and cooling the refrigerant. My fourth concept is transient cyclic behavior or thermostat control. So the temperature inside the refrigerator is not steady, it is transient and cyclic. So when the compressor turns on, the temperature inside drops very quickly. It is the cool down phase. When it reaches its set limit, the compressor turns off and the heat starts to slowly leak in. Also, when we open the door of the refrigerator, the sudden transient spike occurs, which the warm air enters in and the compressor turns on. And my fifth concept is irreversibility. So the refrigerator doesn't create cold, it moves the hot air from inside to outside using the electrical work. And according to the Thermodynamics second law, the heat flow cannot go from cold to hot. It uses the compressor to provide the necessary work. And some of the work is wasted in the form of heat. and irreversibility from the friction and pressure drop. So that's why of the refrigerator back are usually warm.